Hi everyone, good evening. Can you all hear me? Starting in a minute from now. Good afternoon everyone, good afternoon. All right, so I think it's time, let's begin. So today what we'll be doing is we'll be solving 20 questions including one coding question on SQL, which is very important. I'll be presenting my screen now and we'll begin. All right, so I hope my screen is visible. So the agenda for today is to get a good grasp on a very important coding question for SQL, which is this question that you can see on the screen. After that, we'll be covering a few questions from machine learning, few questions from statistics, and few questions we'll be covering from Python. Again, these questions might you have seen, but there are higher chances that what questions I'll be bringing on for you today, you might have not seen them. There are more chances, more is the probability for that. And the second thing is that these questions are very, very, very important. As we will solve those questions, as we will look at those questions, I'll also be explaining you. And like previous time, we'll be having a timer that we will be running on as we go. So I hope everything is clear to you. You have a pen and paper along with you so that you can solve along with looking at the lecture. And one more important thing is that I want you all to be active wherever you feel you have a doubt, wherever you feel you have an issue, wherever you feel you are not able to understand something, please definitely ask me. All right, so I think we'll wait one more minute and then we'll begin exactly at 3:25. Till then you can keep solving this particular question. So I've brought 20 questions today, and again, these are very important questions. If you know the answers very well, right? If you are not able to solve them, that's completely fine. We'll solve it together. But to track yourself, as in the first session I mentioned, please have a paper and pen, mark what topic is your weak, what topic is your strength, and you'll be able to do that with the help of a basic tally mark kind of a table, right? Okay, so I think it's time. Let's begin now. So I'll start a timer. You will have 120. Okay, I'll give you a bit more than 2 minutes to solve this particular question. Once you have came up with an answer, please share your queries in the chat. You can solve this particular question using a correlated subquery. You can also solve this question using window functions. So any way you solve it, up to you, doesn't matter. You can solve it using a CTE along with the window function. You can solve it using a subquery, a normal subquery along with the window function. You can solve it without any window function using correlated subqueries. So I don't want the answers right now, Uma. What I'm waiting for you all is to write the code, right? Write the code for it. Write the code for it. However you feel. You may use a rank, you may use a dense rank, whatever you feel. First, the importance is that I want you to write the query. It's very important that we all write the query. All right, everyone, less than a minute, 45 more seconds. All right, 15 more seconds. Do we have any answers? Any one of you? Can you answer it? All right, so I think I've given enough time. Now I'll move on to the solutioning part of it. Okay. So I'll also point out a very common mistake people tend to do when they solve this particular question. It's important that we understand that so we do not make this mistake going forward. This is a very important question, a very, very important question when it comes to SQL interviews, when it comes to your SQL test, a very important question that is asked and a very standard question as well. Like people expect you that you have seen or done this question somewhere at least, right? They expect this from you. So now the standard question that is generally asked is generally they ask, okay, what is the second highest salary for each department? That is what generally is asked. And here we see an extension that instead of just second highest salary for each department, I'm also saying that do not include the departments that have fewer than 2 employees. So this is an extension to that particular question. Now what a lot of people will do is, I'll talk about the very standard problem. We'll come to this excluding 2 employees later. What a lot of people will do is they will use a ranking function. They will say, okay, dense rank over, and then they will use partition. Everything of this they will do. Okay, partition by department, order by salary. They will write this here. This will be their select. Select, they will say employee ID, employee name, whatever columns are needed. And then they will say, then dense rank over as rank of salary, salary rank, whatever. And then they will say, okay, where rank of salary is equal to 2. But this is wrong. This syntax is wrong. The reason is that where function is executed after, where function is executed, before your window function. So if your window function is not being executed, then from where will you get the rank salary is equal to 2? So definitely I will understand that, hey, you understand the window function from here. But what is more important is that you guys are not able to focus on the major part, that window functions are, one second, just let me remove all of this from last time, 1 second. Okay, so what you're not able to understand is that the window function is executed after your where. As we had talked about in our interview session, I think we talked there about the order of execution in SQL. I think it was in that or the first lecture of interview prep or the first one for test prep. I'm not very sure. But there we talked about definitely, what is the order of execution in SQL. And there we talked about that window function is executed first and then comes your second part. So that is the most important point that you have to keep in mind over here. Hence, you cannot use a window function and directly apply a where. What you can rather do is, you can say that, okay, I will rather use my window function, one second. I will rather use my window function in a form of subquery. I will enter my window function in a form of subquery and select everything I want from here. So one way is this you can do. Another way that you can do is by creating a CTE, common table expression. So what CTE does is it helps you define 2 to 3 multiple queries at once. So as we can see in our solution over here, we have solved it using the CTE. So how we have solved it? We have said that, okay, we'll select all the columns, employee ID, employee name, salary, employee name and salary, then we'll select the department. Now we will use dense rank. So dense rank why we are using? To get the second highest salary. So we'll use dense rank over partition by department. Now we are not using rank 2 because it might be that 2 people have the same salary and we are getting third then. We don't want this. We want the second. Also, we want all the people having the salaries which are second highest. So we want dense rank. In case if I would have took a rank function, then I would have missed the second. There would be no second. In case I would have taken a row number, then I would have missed the 2 people that have the second highest salary. Hence the right one to use is a dense rank. So we use a dense rank. We say, okay, now what we'll do is partition by department. We'll divide the groups into departments. We have divided the groups into departments because we want salary, second highest salary for each department, in each department, right? Now order by salary because we want the second highest. Therefore, we will be using descending over here. Now, second thing important, the extension is we also need the number of employees in each department, because the question is saying over here that do not include those departments for which there are fewer than 2 employees. You do not have to include those. So again, we can create a window function for this. We can say, okay, count star and then over, because we don't have to order. We are just simply counting. So the order does not matter. So we just split them into groups. Partition by groups is all we do. That is all that we need to do. We rename this as department count. We rename salary as salary rank. Now this common table expression is ready. And the name of this common table expression is ranked salaries. Now this ranked salaries can be used in the next query. So what you are seeing over here is that in our next query, what we have done, we have simply taken from ranked salaries, select all the columns, employee ID, employee name, salary, department, we select all of those. We simply say, okay, now I can apply a where function because this table already has the entire information. This table already has employee ID, employee name, and it has salary, it has department, it has the rank, whatever the rank is, 2, 1, 3. It also has the count for each department, whatever the count might be. It already has that information. You've already calculated it using common table expression. One way you can do is using like this. Otherwise, what you can do is, let me just clear the screen. So otherwise, what you can do is you just take this entire thing and put it as from and just copy paste this over here. That's all you need to do. It will become a subquery. As simple as that. So whenever you are having a confusion understanding what subquery can be used, use CTE. Create different queries using CTE and you will automatically understand where my subquery, what I need to put in my subquery. As simple as that. Now you are saying, okay, you're just filtering on it, where salary rank is 2 and department count is greater than equal to 2. That's the complete answer. I hope it is clear. If you have any doubts, please let me know. So one takeaway from here is that window functions are executed after where, and hence you cannot write it the opposite way. You cannot write select from window functions where salary rank is equal to 2, this will not fetch the correct result. Second, we understood that one way to counter this is using subqueries. Another way to counter this is using CTEs. And CTE is more important because CTE is more easy and more important. Why? Because if you're able to create a common table expression, then you know that you just have to replace whatever you write in your first query, in your common table expression, whatever you write it, you just have to replace that as your subquery and the answer will come. So you understood the second part as well, that how subqueries can be easily created. I know a lot of us do struggle with subqueries, that what should be the subquery, how will we solve the subquery part, right? But it's so easy. If you're able to make one query, you will able to immediately put it into the another part. Now, one more important part, since we're talking about subqueries this much, I'll also point out that subqueries can be used in various different aspects. So where subquery can be used is, it can be used with where, but in where your function is not aggregated. Your function expects only one row. Sorry, your function expects, for your function can have multiple values, but for having, what I mean is your function is aggregated. So your subquery should only return one value, because you have an aggregated function. With where also you can use a subquery, saying for example where marks is equal to, and you can run it for different rows, or where you can say list in, you will get the different list in, right? For having, it can be only aggregated function, so a subquery should only return one value. You can write a subquery over here and it should return only one value. Similarly, you can use it in from, in just for example in our case. And there is very interesting another aspect of subquery is that, for example, you are writing select 1 divided by something. Here also a subquery can come, which will return one value. Here also you can put a subquery, right? So you can use subquery with where, having, from. You can also use subqueries inside select while performing different mathematical operations. But because you're dividing, you will need one. So one value is what it takes, right? So these are the different ways that subqueries you can use. And there is a very advanced version of subqueries called as correlated subqueries, which actually changes each time a new row appears. Basically, the correlated subqueries run one for each row. Once it will run for this, once it will run for this, one it will run for this. But uncorrelated subqueries will run once only for the entire data. Might be we'll cover these in the coming up sections, but because we were talking about this, wanted to just give you an understanding that there exists something like correlated subqueries, which might be of help. Okay, now let's move on to the next particular question. And this is a very simple question. I would want you to take 60 seconds and come to an answer for a question number 2. I've started the timer. Please put the answers in chat. Let's see how many answers today you all can get correct. The more the merrier. And the purpose of this is that soon as we move towards more sessions or move towards the ending, you will have a good understanding and you'll also be able to solve all these questions that I bring up. Your marks per session, your score per session will start improving, right? So now try to answer this particular question. Let's see if your answers are correct. Answer is A. Okay, anybody else? Anyone else? The timer is up. Now I'll be solving it. So this is not traditionally what we learn for decision trees, but what we should be very aware of, right? And Tanish, the option is not D, the option is A. The option is A. Now let's understand why. So what the question is saying is, in case of decision trees with categorical input features, so this also matters, guys. If the category, if this is, let's say, for example, I'll take two examples. This is, let's say, position that person works in, data analyst or data scientist, making it very easier for now. Then let's say experience, whether the experience of this person is high, low, medium. And the target variable for this, we'll take it as a continuous variable, as it is written over here. In case of decision trees with categorical input features and a target feature as continuous variable, so let's take it as a salary, 10K, 20K, 30K, something like that. Okay. What is the correct type of metric used to decide the split? So the important point over here to understand is, first of all, ideally what you learn is that, okay, I'll use a Gini index or an entropy. So what do Gini index and entropy do? If in case the salary was not a continuous variable, but rather, if I change 1 second the color of it, so let's say instead the salary was high salary, low salary, medium salary. Let's say the salary was like this. It was categorical. Then guys, you can use, guys and girls present here, then only you can use what we call as, 1 second, measures of impurity, Gini index, entropy, and information gain. Because there, what you're trying to do is that let's say there are 3 high salaries, 2 low salaries, 1 medium salaries in your root node. Now you have divided them. So 1 medium you have got here, let's say 3 high, 2 high and 1 low you have got here. Let's say 1 high and 1 low you have got here. So there your purpose is that your sample is very pure. And how do you define it pure? You define it on the basis of classes it has, on the basis of categories it has. But here, there are no categories. And hence, Gini index, entropy cannot be used. You cannot measure how impure a sample is because it is now 10K, 20K, 30K. This is how your sample looks like now. 40K, 50K, 70K, 90K. You cannot use a Gini index and an entropy. So what can you use? So in this particular case, let me just clear the screen. In this particular case, what you can use is, all right. So in this particular case, what you can use is as simple as that, variance. A lot of research papers also call this as MSE because in machine learning, we generally use MSE, not variance, right? But both are same, mean squared, right? We have to take mean squared deviation, right? Nothing but 1 upon n, the number of data points. Then we take for each data point, I will calculate from first data point till n data points, because I have n data points, the yi, that data point's value, minus the y bar, which is the mean, and we take the square of it. So now what we will do is, we have 2 columns, one which is experience, which is high, low, medium, one which is another one was what? I think position, which is data analyst or data scientist. Then we had the final, which is salary, which is 10K, 20K, 30K, whatever different values we have. Now what we do over here is, in this particular case, we will make the split on, let's say, first the experience. On experience, we get 3 locations, high, low, and medium. So for these, we will have multiple different salaries in this bucket. We'll have multiple different salaries in this particular bucket. So what we will now do is, we will calculate weighted variance, weighted average variance. What do I mean by weighted average variance is that you will calculate the variance for this particular child, for this particular child node. You will say, okay, let's say there are S samples in total. Let's say there are S1 samples here, S2 here, and S3 here. So you will say 1 upon S1, then you will calculate nothing but yi minus y bar square for I equal to 1 till S1. This is how you will calculate the variance for this. Similarly, you will get a variance V2 for this. Similarly, you will get the variance V3 for this. And let's say for this, it is called as V1. Now, what do I mean by weighted averages? Weighting is done on the basis of number of samples in it. So we have S1 samples in our first node multiplied by V1 variance plus S2 samples in our this node multiplied by V2 variance plus S3 samples multiplied by V3 upon total samples, that is S1 plus S2 plus S3, which is nothing but your S. Which is nothing but your S. Similarly, now what you will be doing is, you will be creating one tree for position. So for this, what you will say is, okay, I have salary, I have two positions, data analyst, data scientist. This will have let's say small v1, this will have small v2, let's say this is small s1 samples, this has small s2 samples. So what you will now do is, you will say similarly I can calculate a weighted variance for this particular system, which is s1 v1 plus s2 v2 upon total s, because s1 and s2 is nothing but total samples here. Now whichever of these features will have the lowest variance, whichever these features will have the lowest weighted variance, will be taken to make a split, and hence your answer is variance. It might also be mentioned as MSE in some cases. You mention MSC. Now one thing I want you all to understand, and I will cover in the coming sections or in the upcoming sessions, one critical thing I want you all to do is that we have understood how it works for categorical input features, but what about how does it work for continuous input features? For continuous input features, let's say experience is now in terms of years. Okay, I'll tell in this session only. So for continuous input features, which is 1, 2, 3, 4, you have over here nothing but, let's say, did we have position, data analytics or data scientist, and then we have, let's say over here, this is experience, number of years, this is our position. We take another one, same, let's say salary. So in this particular case, how will things work? Now, for the first one, it is pretty simple. You will divide it into positions, data analytics, data scientist. You will say, okay, variance is V1, S1 plus V2, S2 upon total S. This is what you will say. Now, what will you do for the second one? How will you calculate for the second one? So for the second one, first of all, you do not know how to divide them. So I will say, okay, experience greater than X, experience less than X. All the values of experience greater than X will fall into this. All the values of experience less than X will fall into this node. Now comes the important part. What is my X? So randomly, and there are actually algorithms for that as well, but it can be randomly as well. It can be also pairwise average. You will take, let's say pairwise average, I take 1, 2, 1.5, 2, 3, 2.5. I take pairwise average and I plot different thresholds, 1.5, 2.5, similarly other thresholds. Now, what will happen is, for each threshold, I will keep filling X value. X is 1.5, X is 1.5. I will calculate the MSE for this. How is my splitting being happen? What is the variance for this? What is the variance for this? And I will take a MSE, weighted average variance. Weighted average variance is what I'll take. I will plot it. Then I will do the same for 2.5. I will plot it. I will have a curve somewhere like this. And for whichever I have the least value or the least, basically I'm plotting MSE, right? Weighted MSE or weighted variance is what I'm plotting. So for whichever I have the least, I will call it as my threshold. So let's say it came to be 2.5. So my threshold become 2.5. Now I will use this MSE based on my continuous feature of experience and compare it with the MSE based on salary, and whichever out of these two are lowest, I will make the split on that. Let's say MSE experience come to be 0.1, MSE salary come, not 0.1, let's take it 0.3. This came to be 0.4, then I will make the first split based on experience. So my first split will be like greater than 2.5, whichever threshold is lowest. In our case, I've just taken an hypothetical 2.5, greater than 2.5. And then further now I can split on the basis of experience. All right. So there is one another variation which I would like you to think about it yourself, which is, what about now, instead of the salary as our continuous variable, let's say salary is our HLM, then in that case, for these two variables, you will be calculating Gini index or entropy or other measure of impurity. But how for continuous variables, continuous input features, how can you come to a Gini index is what I want you guys to figure out after the session is over. So guys, this is how actually the decision trees are working. What all knowledge that you might have so far, if you had all this entire knowledge, very well. But if you only knew about Gini index and entropy and information gain, then this is only when the input variable is categorical and also your output variable is categorical. Basically, output variable being categorical means nothing but classification. But in real life, you will not get only categorical variables, you will get continuous discrete variables as well. And then you will use this thresholding logic that we've learned. And also another case is what you are trying to predict. If you're doing regression, then instead of Gini index, you are using MSE or nothing but weighted variance. So these are very important things that you all should be aware of. You cannot think that okay यार मैंने तो entropy, Gini index, information gain पढ़ लिया, अब तो chill कर देते हैं, क्या ही फर्क पड़ता है. Guys, everybody will know this. Guys and girls out here, all of you will know it. But there are only very few people who will be knowing the real crux of how the decision trees are actually working on real data. Okay, I hope it is clear. Any doubts, please let me know. Now let's move to the next question. As you can see, the answer is variance. The third question is up on the screen. 60 minutes again is what will I give you to solve this particular question. Today actually my team has tried to put in good questions of decision trees, basically all trees combined. So can you tell me the answer for this particular question? 60 seconds is what you have. Okay, I think the spelling is a bit wrong over here. I'm sorry for that. So this should be separate. Okay, please start posting your answers. What will be the answer for question 3? You have 20 seconds more to go. If you're not aware of the answer, you can just put any option according to what you feel your gut feeling is telling. Might be correct, might be wrong, but it's okay. We're just practicing right now. Okay, so our beloved Bangan is saying none all the models require a validation set. Okay. All right, time's up. I think I've given you a few extra seconds as well. But the correct answer to this question is random forest. Random forest does not require a separate validation set because of its property of, very good Abhishek, because of its property of out of bag samples. Because of its property of out of bag samples. Now let me explain you what is happening. In random forest, we have multiple decision trees. For now, I'll just draw 3 trees. Doesn't matter what the structure is, right? I'm just explaining you guys. I know my drawing is pretty good, right? Now, because in random forest, I have a data and this data is not entirely fed. All the rows and not all the columns are fed. What happens is, when you make one decision tree, you randomly select 2/3 of the data generally. It depends on algorithm. Sometimes it can be more, sometimes it can be less. But generally the algorithms pick 2/3 of the data. And out of this, let's say we select this 2/3 of the data. We do not use this remaining data. This data we use for training this particular decision tree. Similarly, then after this decision tree is done, we'll also be selecting randomly columns over here called as bootstrapping. Now, secondly, what will happen is, again, randomly, we will select for the next decision tree. Now let's say we select these two parts of data. So these two parts of data will be sent to our second decision tree. So what I'm trying to say is, let's say I have sample 1, sample 2, sample 3 and sample 4. It might be possible that sample 1 is being used for training for decision tree 1, for decision tree 2. But for decision tree 3 and 4, sample 1 is not being used. So for decision tree 3 and decision tree 4, sample 1 becomes an out of bag sample. OOB, out of bag sample. So now what will happen is, similarly, let's say about 2. So 2 was used on this, was not used on this, was used on this, was not used on this. Similarly, 3 was not used on this, was not used on this for training, was used on this decision tree for training, was used on this decision tree for training. So now what will happen is, after entire training is done, after all these decision trees are ready, these out of bag samples will be used. So your sample 1 will be used for validation. Now what will happen is, your sample 1, the prediction of sample 1, the output of the sample 1 will only be on the basis of those trees where it was an out of bag sample. For those trees where that particular sample was not used. So for training, so for this, we know 1 was not used. For this, 1 was not used. So for 1, this will make a prediction. This will make a prediction. In case of regression, we will take an average value. In case of classification, we will take a majority voting. And once that majority voting or a regression value comes out, we will get a predicted value for sample 1. We'll get a predicted value of sample 1, and we can calculate our metric for accuracy or whatever using yp minus y actual, whatever is your metric, right? Whether it is an accuracy, whether it is a regression based R square or something, whatever metric is. Now for sample 2, this decision tree will predict, because here in training it did not use sample 2, and this decision tree will predict. So then you will get a y predicted for sample 2. You will feed it to the metric. Now for sample 3, this one and this one will be used for prediction, and you will put it into metric. And in the end, when all these samples are done, you will get a metric which is for your validation set. So this hyperparameter is generally mentioned as OOB. If set to true, this entire process is done and you do not need a separate validation set for random forest. If it is set to false, you will not get this done. You will need a separate validation set for random forest. All right. So random forest actually does not require a validation set. One training data can be used for both validation and training. If you have any doubts, please let me know. I'll move on to the next particular question. So you can see the answer is third, which is random forest. Okay, another interesting question regarding the ensembling techniques. I'm giving you all 60 seconds to start with. In boosting, how is the final prediction of the ensemble model generated? By averaging the predictions of all weak learners, by selecting the most confident weak learner, by majority voting of weak learners, by combining the weighted output of all learners sequentially, by using only the last learner's prediction. All right, everybody, what is the answer for this? So I've got one answer. Okay, not yet. 25-30 seconds more, everyone. D, but combining the weighted outputs of all learners sequentially. Okay. All right, time's up. Time for answers, everyone. Time for me to solve it. Alright, so the correct answer is option D. A lot of you have got it. That's pretty good. So by combining the weighted outputs of learners sequentially is the answer. So this question, a lot of people think that boosting means we combine weak learners in series. So when we combine weak learners in series, what happens is this model learns on this model learns from this model learns from this. Basically errors of model 1 are learned by second model, errors of model 2 are learned by third model, errors of model 4 are learned, errors of model third are learned by the fourth model. This is what happens. But guys, we do not get one final prediction. This does not happen. Averaging the predictors of all weak learners, we do average them, but it's not just the average. It's a weighted average. And it's different for different cases. So in case of ADA boost, what happens is your error, let's say, is 1. It's a whole alpha situation, 1 minus epsilon, 1 minus e, and all that log and everything will come into picture. But I'm just explaining you in very simple terms. In ADA boost, basically the models which are performing better are given more weight while prediction. So let's say it's a case of regression, and for ADA boost, what ADA boost will do is it will say, okay, error 1, this means that the model is performing this much good, multiplied by the value predicted by model 1. Error 2, because this is how good the model is performing, hence I'm taking a denominator, multiplied by the value predicted by the model 3. Similarly, R4 divided by 1 upon E1 plus 1 upon E2 plus 1 upon E3 plus 1 upon E4. This is the answer. This is the answer. For ADA boost, therefore, the weighted outputs of all learners are combined sequentially. Now, not always the weighted outputs are given weights of an errors. In case of, for example, boosting, just boosting, in case of that, actually what we use is gradient boosting. What I mean is, excuse me, in case of that, the outputs are actually combined on the basis of the step they have taken in each gradient. The amount of step they have taken, that is how they are combined. So first of all, this option is wrong. Some weight is definitely assigned. By selecting the most confident weak learner, no. By majority voting of weak learners, no. Again, when it comes to majority voting, the voting will give more preference or more weight to that particular weak learner which is performing the best. It's not simple majority voting. Therefore, the correct answer is option B, and E is also wrong. As I mentioned, that your model does not give one final prediction. That is not the case. Now moving on to the next particular question. If you have any doubts, please let me know. Is the fifth question. Please try to answer it, everyone. A very important question. I think this question was asked from me as well. Let me remember in which interview. I think it was asked to me in Swiggy. Yes, in Swiggy interview for data scientist, this question was asked from me. All right, everyone, please try to answer this particular question. I'm seeing that people are not answering as much as they used to. It's okay, even if you find the questions to be tough, it's good. You're learning. You're learning. A bit, Rubel. You've missed 4 questions. Don't worry, watch them later. Very important 4 questions. All right. So the main purpose of here is, everyone, that it's okay if these questions you feel are tough. At least you're learning something. It's okay if you're feeling these questions are easy. That means you can feel more confident, right? In any of these scenario, we need to be positive. We need to stay positive. That's why the majority of the blood group is be positive, right? So let's be positive. Let's keep the momentum going. Even if you find it difficult, you will slowly start getting a hang of things. Even if you find it easy, you still find 1 or 2 things that you might not know, and you will be getting it from here. And it's a good way to, test yourself whether you are doing good or not. All right, I think I've given enough time. I didn't even start the timer. Okay, I'll start 60 seconds for now. And Please answer this particular question. You might need a minute or two to think about this question, so it's okay. How this particular question can be answered. One second, guys. Just having a sip of water. It's a little cold here in Bangalore. Having a bad cold, drinking warm water because of that. Okay, so time is about to get up. All right, 5 more seconds from my side. Please throw your answers in the chat. Whatever answers you have, please put them in the chat. All right. So C. Good, Uma. Very good. Very good, Umang. And Uma. Very good, Tanish. Very good. So you guys are nailing it for this one. Amazing. So basically, what happens is when you're talking about a log loss. In log loss, what do? You say I will calculate the probability of yi into log of yi for class 1, right? Sorry, this is y actual and this is y predicted, right? And then you will say, okay, what I will do now is I will take y predicted y actual 1 minus y actual, which is nothing but 0. Let's take it as y actual only, right? Y actual for 0 class and log y predicted 1 minus y predicted, because we are talking about 0 class. So this is what we'll do. Now what is happening is the question is saying that you have to give more importance to minority class because this is less in terms of number of sample. So if class 1 is less, what I can do is I can simply assign a weight w1 for class 1, which is nothing but this will be 1. Y actual will be 1 in this case, right? You'll do this for all I is equal to 1 till n, right? I is equal to 1 till n. You'll do this. And then you will have your w2 multiplied by, you will have your nothing but 1 minus y only, 1 minus y actual, 1 minus y actual, which is nothing but it will also be 1 because this is 1 minus 0. And then you will have log 1 minus y predicted, your value over here. And because you want to assign more weight to this, particular class, you will say that, okay, w1 will be greater than w2. A general rule of thumb is that you can assign on the basis of number of samples. So for w1, if you want to assign more weights, let's say the samples for class 1 is n1 and for samples for class 0 is n2, then n2 upon n1 plus n2 is the weight you take for w1, and for w2 you take n1 upon n1 plus n2. A very simple way of taking these weights. Because n2 is more, therefore w1 will be more as per what we need, that w1 should be greater because n2 is greater than n1. Then by substituting these weights, it's pretty simple that what we'll get is the answer C. Modify the loss by assigning class specific weights, because by assigning a weight which is higher, our errors from here will be given more importance compared to the errors from the class 0, right? For example, let's say error from this class will be 2 into 1 into whatever log p. From here it is only 1 into wt is only 1 into log into 1 minus 1 by p. So I'm giving this too much importance. Now why I'm giving this too much importance? Because in this case, for simplicity, I assumed that my class 1, the samples of class 1 is twice that of N2. N2 is 2 times of class 1. So I give twice the weight to sample 1. I give twice the weight to class 1 and only 1 weight to class 0. So in this way, you can assign the weights such that it does not only focus on calculating the error of the majority class, and a minority class is also being considered. All right. If you have any doubts, please let me know. I think this might be clear. A lot of you already got this correct. I'll move to the next one now, which is the question number 6. Okay, so this question is based on binary classification, entropy, and Gini index. A pretty simple question, and I'll give you 60 minutes, 60 seconds, sorry, not 1 hour, obviously, right? Please also read carefully that select all that apply is mentioned. Select all that apply is mentioned. So read carefully and answer. Everyone, quickly. It's pretty simple. I should start getting the answers. Abhishek says 1 and 3. That's an easy question, guys. A follow-up question for those who have answered. What is the maximum value of entropy in case of n classification? Basically, n class classification. All right, timer is up. So this was a pretty simple question. Most of you got it correct again. That's pretty good. So the correct answer is Gini index, whatever you call it, is computationally faster compared to entropy, because Gini index is nothing but what you do is take the square of probability of each class. Let's say there are classes from 1 to k. There are k classes. So you take this. For binary classification, it will be nothing but P of I. We have 2 classes. I is equal to 1 till 2. We take the square of it. But for entropy, what we take is the logarithms. We take the logarithms, everyone. P log of P, right? And for all the classes, we take a summation of this. And entropy, because it takes logarithm, it becomes computationally slower compared to our Gini index, which is just a square, and faster. Another important thing is that entropy has a maximum value of 1 when it comes to binary classification or any classification, but when it comes to Gini index has a maximum of 0.5 when it comes to binary classification. As you can see, a sample having completely imbalanced data, basically not imbalanced, what I mean is like 2 classes in equal number, I will get 1 by 2 square, 1 by 2 square, subtract these, this will be nothing but, you can calculate, 1 by 4 into 2, 1 minus, which is 0.5. So my Gini index for my binary classification has a maximum value of 0.5, whereas for entropy also you can calculate the entropy maximum value is 1. But in case the binary classification was not mentioned here, then the thing might change. 1 second, let me just clear the screen. So now what happens is, let's take 3 classes. If you try to calculate the Gini index for this, it will come out to be 1 by 3, 1 by 3, 1 by 3, and 1 minus all of this. This will be what, everyone? This will be nothing but 3 into 1 by 9, which is 1 minus 1 by 3, which is 2 by 3, which is 0.66. So one important thing I want to tell each one of you is that the maximum of Gini index increases if the classes are increasing. Right? The maximum is not 0.5, it actually increases. For 4 classes, it will come out to be, I think, 4 by 16, which is nothing but 12 by 16, which is 3 by, sorry, just 3 by 4, and is 0.4575. So guys, understand that whenever we are speaking that Gini index maximum is 0.5, we're actually talking about binary classification. The value increases, the maximum value for Gini index increases as the number of classes increase. Alright, but still the answer 1 and 3 are the correct answers because we are talking about binary classification. Okay, I hope this is clear. Now I'll move on to the next question. If you have any doubts, please let me know. Alright, we can see 1 and 3 are the correct ones. Sorry, didn't mean to do that. 1 second. Question number 7. Take 60 seconds to answer this question. No, Tanish, it's not n minus 1 by n. And that is also not 1 by n, Tanish. That was a pure sample. If your sample is not pure, it will not be 1 by n, right? That will change. If your sample is not pure, then this will entirely change, right? This has 1, 2, 3, 4, 5, 6, 7, 7 things, right? Yeah, max value of entropy remains same. So it has 7, right? So for the first one, you will have 2 by 7. For this one, you will have 3 by 7. For this one, you will have 2 by 7. So 1 upon n does not make sense. Oops. All right, everybody. What is the answer for this question? Yes, Uma. Take 10 more seconds. Ten more seconds, everyone. Start putting answers in the chat. I'll actually give you 20 more seconds. I'm not starting the timer now. Just giving you a few more seconds. Alright, I think I've given enough time. I should start seeing some answers now. Alright, so Abhishek has answered C. Even if you have seen the answer, guys, just answer it. Doesn't matter, right? At least I'll know that you are actually trying to solve. Alright, so the answer is bias increases and variance decreases. A very good question I have came across while learning random forest myself is this particular question. Now, you will likely answer B if you're not clear about how the trees are being formed in a random forest, right? So the answer is C. Now understand what is happening. So at each split, for each decision tree, for each split, you decide the number of columns you will send to it. Then you will calculate Gini index or MSE, whatever is more important, whatever you're doing, classification or regression, you will calculate that. And on the basis of whichever has lowest Gini index, lowest MSE or maximum information gain, you will then decide which column you have to make a split on. Now, which column you have to make a split on is only coming out of the predefined columns that you will send to the decision tree. And at each split for another decision tree as well, different set of columns will be sent. For next split, different set of decision tree columns will be sent. Different set of columns will be sent. These columns are randomly selected. Few algorithms by default select 3 columns. Basically, independent feature will always be there. Our target variable will always be there. Apart from that 3, it selects features on which then it decides what will I make a split on. So by doing this, if you remember, I had talked about in our first session that decision trees in a random forest are not only independent but are also uncorrelated. Imagine if I would have created decision trees by sending the same data and sending the same columns, all the decision trees would be nearly identical, behaving the same way. All these decision trees, if entirely the same data is being said, same columns are being sent, they will behave the same way. So if this model is making an error due to noise, due to high variance, this decision tree model will also make an error due to high variance, high noise. Both of them will make an error on, let's say, sample 1. Both of them are likely to make an error on sample 2. If one is making an error, another is also likely to make an error because they are highly correlated. And because they are highly correlated, my averaging effect goes away. Now, what is this averaging effect? I will talk about it at the last. Now come to this uncorrelated decision trees. Better are the chances here where one will make an error at, let's say, sample 1, this made an error. Better are the chances that this will not make an error. Lesser are the chances for this, for making an error, because they're uncorrelated. So ideally, if I have such decision trees in my random forest, better are the chances that majority of them will not be making an error because of noise, because of variance. Why? Because in the end, I will take either average of the k run decision trees, or I will take majority voting of k decision trees, and I will be able to average out the error, or nothing but the error coming because of learning noise. Error because of noise. And because of noise is nothing but variance. In this particular case, if all of them are highly correlated, they will be making error at the same time. So the averaging will not help much. And I will not be able to reduce the error effect. Here I am reducing the error effect. Over here I will not be able to reduce the error effect because of coming from variance. So variance will be high. Here variance I am reducing. Now another thing is that if I'm talking, one second, sorry, I think I've started something. All right. So one more thing, if at each split, I'm giving more number of features, as we are saying, we increase the max features. So basically this feature controls the number of columns I'm sending here. So if I'm saying, let's take max features as total number of features that were initially present in my data, in my training data. If my max features has a maximum value, which is equal to total number of features, then what will happen, everyone? Okay, Rubal, definitely watch the recording. Then what will happen? You are basically saying that all the trees will be correlated, and if all the trees are correlated because they're getting same number of columns, there are more chances that they will be selecting same columns for making a split. They will be high correlated, so their variance will increase and bias will decrease. And sorry, I said C is the answer. B is the correct answer. I don't know what I actually read this as you decrease. That's why I was saying. So B is the correct answer coming out from this particular question. I hope this is clear to each one of you. Now moving forward to next question, I will now clear the screen. If you have any doubts, please let me know. One second. Right, so B was the correct answer. As you can see, bias decreases, variance increases. That is what you all guys understood from what our explanation was so far on that. Now let's move on to the next one, question number 8. What should you conclude about the feature selection and multicollinearity handling? You're given different options. You need to select which one is the correct option. I will give you 60 seconds for this particular question. "60 seconds for this particular question, everyone. Try to solve it. Alright, Tanish, Suparna, Uma, Abhishek, Samyak, what are the answers? Everyone, 30 more seconds. The rest of you are not answering. Try to answer, try to interact. If you're enjoying so far, if you're gaining something out of it, don't forget to help us as well by just hitting the subscribe button, liking the stream. There are 2 to 3 things that you can do to give us back in return for the efforts we are putting in. And that means a lot for us, for everybody at Data Avengers. It means a lot. Alright, time's up. Let's talk about the answer. So the answer for this question is, Lasso aggressively selects one feature among collinear ones, but this selection is unstable. So this question helps you understand 2 important things. The first part of this question is about multicollinearity. So let's talk about multicollinearity. Feature selection we already know, right? The feature selection that Lasso or L1 regression helps in feature selection, and Ridge does not help in feature selection. We're already aware of this. But now the question is extending to multicollinearity. And that is what makes it a slightly difficult question. So when it comes to multicollinearity, what ridge regression will do? Ridge regression will pick all the features. Let's say we have column 1, column 2, column 3, which among are highly multicollinear. Ridge regression will pick all the C1, C2 and C3 because it cannot do feature selection. So it will include all C1, C2 and C3. But the coefficients of C1, C2 and C3 will be highly reduced to make sure it is stable. To make sure that linear regression is stable. What happens is when you put in highly multicollinear columns in a linear regression without regularization, no regularization is being done, then the coefficients of these columns are highly not interpretable. Why they are not interpretable? Because on a slight change of your training data, B1, B2, B3 will change hugely. Let's say on your training data look like this, B1 was here. Your training data changed slightly, your B1 will fluctuate huge. Your training data changed slightly, your B1 will again change. Same will happen with B2 and B3. So when it comes to multicollinearity with normal regression, these will become highly interpretable. But ridge regression will reduce these features, the coefficients of these features, to make the linear regression with ridge regularization more stable. And hence, in case of multicollinear features, you can prefer ridge regularization. Now let's talk about lasso regularization. So what happens is, in lasso, because it will do feature selection, it will pick any one column at random. Any one column at random and will drop the other two features. But which feature it picks up at random is highly unstable. It might pick this feature. It might say B1 has a value, beta 2 becomes 0, beta 3 becomes 0. But again, because of fluctuations, it will not be able to control these fluctuations. So as training data changes from this to this, it will say, okay, beta 1 is 0, beta 2 is some value, beta 3 is some value, beta 3 is 0. It will start fluctuating hugely. That is why even though Lasso aggressively selects one feature among collinear ones, but Lasso is not preferred because this selection is unstable. Hence, if you have multicollinear features, you should go for ridge regularization. It will make your linear regression more stable. Okay? They do not eliminate multicollinearity completely. As we can see, ridge does not eliminate it. Lasso tries to eliminate it, but it is not stable. And Lasso is more stable. That is also wrong. Ridge regression sacrifices interpretability to reduce overfitting. This is not talking about multicollinearity. This is a wrong option. Lasso aggressively selects one feature among collinear ones, but this selection is unstable. The correct answer is C. Alright, if you have any doubts, please let me know. Otherwise, I'll move to our next particular question. We can see C is the correct answer. Moving to the ninth one, a pretty standard question of SQL. Let me give you 60 seconds to answer this. Alright, it's okay, none of you got it right, that's completely fine. It was coming directly from one of the research paper. Let's see what is the answer to question number 9, everyone. 40 more seconds. More seconds, folks. Welcome back, Rubel. C is the correct answer. Correct. Guys, this is a very, very, very important question. I'm emphasizing on this because it is very important. I'm not joking. It is a very, 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 very important question for data analytics and data science SQL particular questions. The answer is C. So what happens is, in SQL, when you use delete, you can use a where. And when you use a where, whichever row satisfy those conditions will be deleted. And where does filtering? So delete allows filtering with where, and this is correct. Now truncate removes all rows without logging each row. So understand that delete also logs the data that it has deleted. In the logs, you can go and check that delete will log the data, basically the rows, it will log them, whatever rows it has deleted, delete will log those rows. But coming to truncate will do what? Truncate will remove all the rows from the table, but the table structure, the primary key, the foreign key, the constraints, everything remains intact. Just drops, or not drops, the correct terminology is removes all the rows, and you cannot see the data that it has removed in your logs until and unless you explicitly mention it. Now comes to drop. Drop will destroy the table structure. There is no table. Your DB has no table. Earlier, let's say your DB had table 1. This table 1 was visible in here. This table 1 was visible in here. But here, table 1 will not be visible. All the constraints, everything that you did so far on this table is gone. It removes the entire table structure from the database. A very important follow-up question on this sometimes can be, specifically it's of a very database heavy role, can be which out of these you can roll back. So I might ask you in the coming sessions which of these are allowed to roll back in MySQL and which of these are not. You can study it yourself, and in the upcoming lecture, let's see if you can answer it. Hopefully, you all will be able to answer it. Now moving to next particular question. Is question number 10. A question based on, I think, window functions. Okay, a pretty simple question. 10 seconds again is what I will give you to solve this particular question. All right, let's see. Thirty more seconds, everyone. Ten more seconds. Please come up with answers. Oops, I think there are two questions with the same number 10. It's completely fine. All right, so time for answers. So the question is pretty simple. It's saying if you have an entire window, you do not mention that which rows it needs to take. Generally with rows, you can mention between preceding to and current row. So basically the window is reduced to between 2 and current row. Similarly, you can mention preceding 2 and following 4. That means current row 2 rows behind and 4 rows front. Unbounded means everything in the window. Doesn't matter where the current row is, everything in the window. Unbounded preceding means unbounded preceding I'll come to first. Unbounded preceding means all the rows before the current row. And unbounded following means all the rows after the following row in that particular window, in that particular group that you have created. So the answer is simple. It is rows between unbounded preceding and unbounded following. But because we have also got a range over here, range is what is generally used as a much more, it's more basically by default range is what it considers. Therefore, the answer is B, range between unbounded preceding and unbounded following. Range and rows are different, guys. Range and rows are different. Rows does not consider whether this whether this data is same or not. It will just directly take, if I say, okay, one row preceding, it will just directly take this row, irrespective of data in this and this were same. What range will do, if I say range preceding one, so for the current, before current row, it will check, okay, these two rows have same data, so I will take both of these rows. So that is how range and rows are different, right? And it takes range by default. So answer B is the correct answer. And I hope this question is clear. If you have any doubts, please let me know. It was actually not a more of a fundamental question, not more of a thinking question, but a very important question that you understand what does preceding, following, and everything mean. All right, next question. Which of the following best describes the main difference between a CTE and view in MySQL? A very simple question. 60 seconds is what I will give you. 1 minute is what I will give you for this particular question. Okay, I think we're getting now a bit of easy questions after all the brainstorming. Forty more seconds, everyone. Put your answers in the chat. Suparna, Uma, Abhishek, Rubal, Abhishek I've already called, Vivek. Everybody, please put in your answers. Samyak. Alright, Uma has said B. The answer is C. Good job, Abhishek. Alright, so time's up. A pretty simple question. Did not need any more time on this. So I'm going to solve it. So what exactly does a CTE do? CTE says with CTE name, you write a query here, then you will say comma, and then you write your main query. As soon as your main query is completed, the execution of main query is completed, the CTE is destroyed. CTE is destroyed. And hence, CTE exists only during the execution of a query it is related to. Now, one more part to this is, whereas a view is stored in a database. Now, what people get confused is, they think that view is temporary. Yes. View does not store the entire data. The data, it does not store. What view store is the query, the structure that you have written. It does not store the data, it stores the query, the structure you have written. Therefore, a view is stored in the database. Even on restarting, you will have a view, which is nothing but your query, stored in your database. Hence, C is a correct option. A very simple question, I believe. We can move forward. If you have any doubts, please feel free to ask me. Okay, as you can see, C is the correct answer. Moving on to the next question. Based on statistics. Statistics has started. I'll give you 60 seconds. The question only needs 30 seconds if you know the right answer. After this, 9 more questions to go. We'll wrap by 20 to 30 more minutes. Hold on, there are many more exciting questions that are coming your way for Python and statistics. ML and SQL are done for today. Moving to Python and stats. 10 more seconds. May I see the answers in the chat? The correct answer is B. Very good. Now, let me explain you how. Okay. So type 1 error is what, everyone? falsely rejecting the null hypothesis. Rejection is called as positive, and false decision makes it false positive. Now what happens is, in which region do you reject the null hypothesis? So assuming null hypothesis is true, I draw a distribution using CLT. This is my population mean, and in this I will have a sample somewhere over here. If my sample lies in the region denoted by alpha, I will reject it. And if I increase alpha, then I'm increasing the region of rejection and increasing the chances of falsely rejecting the null hypothesis. So if alpha is increasing, my type 1 error is increasing. If alpha is decreasing, my type 1 error is decreasing. So type 1 error decreases is what we have come to so far. Now coming to the second part, type 2 error. So let me clear the screen. For type 2 error, I will draw two graphs. One assuming my null hypothesis is true and the population mean is mu. One assuming that my alternate hypothesis is true and my population mean is mu1 rather than mu, and mu1 is greater than mu. Now what will happen is, I will draw two graphs. Assuming my null hypothesis is true is this one, my alpha is this particular region. Now I will draw another graph assuming the alternate hypothesis is true, and I will get a graph like this. So if case, I will have my mu over here and my mu bar, mu1 somewhere over here, corresponding to this curve, corresponding to this curve. Sorry, I drew it a bit sidewards. Mu will be over here. Now, type 2 is falsely accepting null hypothesis. In which region am I accepting the null hypothesis? You can see you're accepting the null hypothesis in this entire region. In this entire region, you're accepting the null hypothesis. This entire region. But that is wrong. Assuming that the alternate hypothesis is true, then I will get somewhere over here only, right? So this entire region and a little of this region, this curve going till infinity, this region will become my region where I am not rejecting the null hypothesis. I'm gonna just undo everything. Alright, so this particular region is that region of this curve. This curve will be like this. So this particular region is where if my x bar is lying, I am not rejecting it. I am not rejecting it. Only in this region I am rejecting it. So this total area is of two parts. One is alpha, this alpha region. One is beta. In alpha, we are rejecting the null hypothesis. We are doing a good job. But where we are not rejecting the null hypothesis is this beta region. And greater the beta region, greater this region of intersection between two curves, greater will be my type 2 error. If I increase alpha, now I will increase alpha. Now when I'm increasing alpha, my beta on increasing alpha, as you can see, has reduced. And if beta is reducing, my type 2 error will reduce. So on increasing alpha, your type 1 error is increasing. One second. On increasing alpha, your type 1 error is increasing, but on increasing alpha, your type 2 error is decreasing. The question talks about decreasing the alpha. So when it's just the opposite. When we decrease, type 1 error will decrease, and when we decrease alpha, type 2 error will increase. And this acts like a trade-off. This acts like a trade-off. And hence, the correct answer is B, that type 1 error decreases and type 2 error increases. It will definitely increase. It's not may increase. Actually, it is may depending upon the, intersection. But yes, it generally does increase. All right. Moving on to the next question. If you have any doubts, please feel free to ask me. What am I doing? 1 second. I need to hide it. Yep. As you can see, B is the correct answer. Moving on to the 12th question. A pretty simple question on confidence interval. I think it's simple. Yes. Now please tell me what is the correct answer for this particular question number 12. Seven more questions after this, everyone. Please hold on. You spent so much time. A little more time will make sure you've got everything from this session. All right, I'll start a timer. I'll start a timer of 45 seconds. I've already given you 15 seconds. Suman says A. Guys, which of the interpretation is incorrect is being asked. 15 more seconds. All right, time is up. I'm getting all the answers. And the correct answer is A. Correct answer is A. Now, what exactly does confidence interval tell you? Confidence interval tells you that you have a sample mean. You have a sample mean. In your sample mean, when you go and say my confidence interval is between x bar minus sigma upon root n into critical z alpha, x bar plus sigma z alpha upon root n. What does this confidence interval mean? You say that your z alpha is nothing but the level of significance that you will take. Let's say we have taken 95%. So what this means is that if you draw 100 intervals, there are high chances that 95 of those intervals will have your population mean. There are 95 intervals which have your population mean. So if you repeat this process many times, 95% of such intervals would contain the population mean is a correct statement. The interval is constructed based on sample. Yes, we are taking sample mean, a correct statement. The interval gives a range of plausible values of population mean, which is correct statement. Now the incorrect statement is this one. 95% chance that population mean will lie in this or not is a wrong statement to use. This is not probability, guys. Here the probability is not 95. Either it will be present, the population mean will be present in this, or it will not be present. And basically, you're repeating the process not with this interval. You're taking one sample, you're constructing it, x bar 1. You're taking another sample, x bar 2, you are constructing it. You're taking another sample, x bar 3, you are constructing it. So when you do this many times, the different intervals that you get out of 95% of those intervals will contain your population mean. and hence you cannot say that 95% chance that my population mean exists in this. That is a wrong statement. Either the population mean will be present, either it will not be present. End of the story. The correct statement is there is a 95% confidence, and hence the answer is A. This is not determining probability. This process is telling you that out of 95 intervals, out of 100 intervals, or out of infinite intervals, 95 of those will have your population mean. There is no talk about probability over here. And hence you can only say the correct statement is there is a 95% confidence that the population mean will lie in this interval. You cannot attach it to probability. Alright? Because probability will say either it will be present or it won't be present. It will not say otherwise. Alright, moving on to the next particular question, which is question number 13. Okay, now we have got another statistics question. 60 seconds for this particular question. Please try to answer this question. Six more questions after this, everyone. Let's get it done. Let's try to score good today. Better than our first session of test prep. BCV means between cluster variance and WCV means within cluster variance. Alright everyone, hurry up. Let's see if you're getting it correct or not. Alright, time's up. The correct answer is B. Good job. Pretty simple question, but a very, very important question. Okay. So basically, when it comes to what is between cluster variance and within cluster variance, I'll explain you that first. So first of all, when it comes to clustered and stratified sampling, we divide the data into different groups, right? We divide the data into different groups, particularly called as clusters over here. And here also we can call those groups as clusters. Now, the important point to understand over here is that, now let's talk about clustered and stratified and separately. The between cluster variance, let's say that I have two clusters or two different groups. In clustered sampling, how am I dividing these groups? I'm dividing these groups based on geography mostly. In stratified, I'm dividing these two groups based on certain attribute. A very crucial attribute. For example, gender, right? Now coming to the next part, what is BCV and WCV? Between cluster variances, how do the clusters vary among themselves? How do these clusters vary? One second, sorry, I drew a wrong one. So how do these clusters vary among themselves? So this varying with this one's, oops. This cluster varying with this varying with this cluster varying with this. What is the variability between these three clusters together? Within cluster variance means one cluster, what is the variability inside this? Second cluster, what is the variability inside this? Third cluster, what is the variability inside this? Now back to our question of clustered and stratified sampling. So let me just clear the screen. So when it comes to clustered sampling, and when it comes to stratified sampling, in stratified sampling, we are dividing on the basis of one important attribute whom we feel, or we feel by dividing on which we will get groups that are similar. Basically one group, all the data points, let's say if I'm dividing by women, then shopping habits of women will be similar compared to shopping habits of men when it comes to buying clothes. So I'm saying that variability within this cluster, variability within my cluster is low. But because men and women have completely different shopping habits, they will have high between cluster variance. When it comes to clustered sampling, I'm dividing the clusters based on geography. For example, if I have 20 schools, I might pick randomly 2 or 3 schools. Now I assume that if I want to understand the IQ of students in this school, or let's say not IQ, let's say if I want to understand the preferences or what the students in these schools want to pursue as higher education, I will get a properly distributed cluster. Each school will have a good distribution, and each school will have a distribution which is similar to my population distribution. Each school will have a distribution which will be similar, very close to my population distribution. And hence, inside one cluster, the variability is high. And therefore, within cluster variance is high. But compared to these, because they are similar to population and hence they are similar to each other, therefore between cluster variance will be low, and hence option B is the correct answer. Alright, if you have any doubts, feel free to ask. Till then, I'll move on to the next particular question. So you can see B is the correct answer. Moving on to the next one. Question based on probability. I'm giving you 60 seconds to solve it. Which one among stratified and cluster will describe the distribution of population better? Okay, Tanish, I've already answered that, I think. Solve this question number 14. I'm starting 60 seconds once again for you all. This might take us a bit of more time. So 1.5 minutes. Five more questions after this, everyone. 15 more minutes, 20 more minutes, we'll wrap up. $20 more seconds for this question. Do we have any answers? Do we have any answers, folks? All right, so time's up. Any answers? None so far. So I'm going to start solving it. All right. So first 6-sided die is rolled. If the die shows 1 or 2, then you toss 1 coin. Second says 3 or 4 if you get on the dice, you toss 2 coins. If it shows 5 or 6, you toss 3 coins. I also don't know the answer. I have to solve it, right? So now, what is the probability of getting 1 or 2? The probability of getting 1 or 2 on a dice is 1 by 3. The probability of getting 3 or 4 on a dice is 1 by 3. The probability of getting 5 or 6 on a die is 1 by 3. Right? Guys, just singular version of dice is die. Right? वो वाला die नहीं मार दो मारने वाला वो सब नहीं बात कर रहे हैं. Okay? Now, if this is happening, you're tossing a 1 coin. If this is happening, you're tossing 2 coins. If this is happening, you're tossing 3 coins. Now what the question is saying, x be the number of heads you get. So what is the expected value of x? So expected value of x, for that first I need to see what is the expected times I will get heads in this case. I know that tossing 1 coin is nothing but a Bernoulli distribution, and the expected value is nothing but p, which is the probability of success here, which is nothing but of getting heads, is p. So my expected value here is 0.5. And how many times am I getting this value? I'm getting 1 by 3 into 0.5, which is nothing but 1 by 6. Now for this, 2 coins, 1 coin toss is Bernoulli trial, multiple independent Bernoulli trials make up a binomial distribution, and I know that the expected value of binomial distribution is n into p. N is number of trials, Bernoulli trials, which is 2, and p is probability of success, which is 0.5. This comes out to be nothing but 1. So expected value of heads I will get is, in this case, is e of x into probability of 3 or 4, which is nothing but 1 into 1 by 3, which is 1 by 3. Now comes the next question. Expected value of 3 coins is again a Bernoulli binomial distribution with n is equal to 3 and p is 0.5. So 3 into 0.5 is nothing but 1.5. So the number of times I'm getting this is nothing but 1.5 into 1 by 3, which is nothing but 3 by 2 into 1 by 3, which is 1 by 2. Now the total number of heads that I'm getting is nothing but addition of these, 1 by 6 plus 1 by 3 plus 1 by 2, taking LCM as 6 common, I'm getting 1 plus 2 plus 3 plus divided by 6, which is 6 by 6 is equal to 1. So the expected number of heads, or on an average, you will get 1 head, is the answer. If you have any doubts, please let me know. Otherwise, I'm going to move on to the next question. This was a pretty good question, a very good question. Very good question. It actually took into case binomial distribution, Bernoulli trials, and also, what do you call that? This expected value. So C is the correct answer, that is 1, right? 1 by 2 plus 1 by 3 plus 1 by 6, which is C. 1 is the correct answer. Alright. Now moving forward to the next particular question, I will give you 60 seconds to solve this question. A pretty simple question again. Alright guys, try to solve it. I'll just quickly go and have a glass of water. I'm coming back guys, hold up. Alright everyone, I'm back. Let's see if anybody of you has answered it. Meanwhile, I'll start solving it. Even I don't know the answer for this. I would need to solve it. So it's a very simple formula if you know this. Variance of a plus b is nothing but variance of a plus variance of b minus 2 covariance of a and b. So the question has given you nothing but variance of a plus b, that is 40, is equal to 10 plus 25 minus 2 into covariance of a comma b, which is nothing but 35. 5 is divided by 2, which is covariance of a comma b, which is nothing but 2.5. Answer A is correct. All right, good job. If you've got the correct answer, I see most of you got 2.5. That's pretty good. Now I'll move forward. Okay, one follow-up question on this. So if covariance of a comma b is equal to 0, right? Then we go and say that, okay, a and b are independent. Okay. Now let's move forward. Okay, I think now Python has started. No, Rubel, it's subtraction of covariance of a and b. It's variance of a plus b is equal to variance of a plus variance of b minus 2 covariance ab. And variance of a minus b I think we did one mistake in that. I'll come to back. Till then, you guys please solve this. I'll start the timer. Yeah, actually there is a mistake. I did subtraction. 1 second. Let's go back once. The question was okay, we'll do this after this one. We'll do this after this one. Solve this one first. Then we'll go back. Took a subtraction, it should be positive. If it would have been variance of a minus b, then it would have been a subtraction formula. I'll write both of them. All right, I'm giving you 10 more seconds. Please solve this. Yes, actually, Rubal, you're correct. It should be minus 2.5, right? I'll come to it. Let's solve this first. All right, so answer C is what you guys, oh shit, A, B, C, you mean 6 and error, right? You mean 6 and error, right? That is the correct one. 1 second. Let me just solve this question once again for you all, because we did one mistake in it. So variance of A plus B is equal to variance of A plus variance of B plus 2 covariance of A and B. And variance of A minus B is variance of A plus variance of B minus 2 covariance of A and B, right? So we had variance of A plus B, therefore 40. We had variance of A, which is 10, variance of B, which is 25, and plus 2 covariance of A comma B. Therefore, this becomes nothing but 35 minus 45 divided by 2 equal to covariance of A comma B, and hence the answer is 2.5 equal to covariance of A comma B. I had taken this one, so the answer was coming minus 2.5. I completely neglected it, wrote something else, took the answer out as something else. My bad, I'm sorry for that. So I had to use this particular formula, right? When Rubel pointed out that, sir, you have taken minus 2 covariance A and B, that's when I realized that I have took the minus 1. Okay, so this is the formula that you need to take. Please keep this one in mind, right? Please, these two are very important actually for your online assessments, especially the companies related to finance and business. These formulas are very helpful there. Okay. Now I'll clear the screen and go to the next question. All right. So now, what is the answer for this question? So I've got answer as 6 and an error is, I think, what the correct answer will be. This will not be counted as tuple. This is not a tuple. This is a integer one. Only if this had to be a tuple, you would have to write 1 comma. Then t1 was a tuple. But this was not a tuple. So t1 is equal to 1. t2 is a tuple of 3 comma 4. Now t1 plus equal to 1 means t1 becomes 6. Print t1 means 6 will be printed. Now t1 plus t2 means I'm adding 6 plus 3 comma 4. Tuple concatenation does exist, but you are adding an integer with a tuple, which is wrong. If in case it was written that, okay, now t1, if in case from here line you wrote one line, let's say here there was one more line saying that t1 is equal to t1 comma something like this, and then you would have done t1 plus t2, then your tuple of 6 comma was being concatenated with 3 comma 4, and answer would be this. An entire new tuple would have been created. But because you are adding an integer to a tuple, this is wrong, and hence the correct answer is 6 and error. Okay? So guys, always remember, this is an integer, this is a float, this is a string, this is a tuple, this is a tuple, this is a tuple, this is a tuple. Okay? So this comma is very important. It changes the data type entirely. Okay? Moving on to the question number 17, third last question. I hope all the questions are clear so far. Now I'm gonna remove, what do you call this? Hide the screen brush, sorry. So we can see this one, 6 and error is the correct answer. Now let's move on to the question number 17. I'm giving you 60 seconds for this. Third last question. Okay, this question is based on copy, deep copy, soft copy. Deep copy, soft copy, guys, come on. We talked about this. After this, we have only 2 more questions. We'll wrap up in 5 to 7 minutes more. So what are the correct answers, everyone? 15 more seconds to go. All right, time's up. Please put your answers in the chat. Meanwhile, we'll start solving this question. So what will be the output of the following code? From copy, import deep copy. Okay, this is soft copy, guys. This is soft copy, and this is deep copy. And this is assignment. And what we learn right now will be valid for all the immutable, will be valid for all the mutable objects. Okay, for all the immutable objects. Now, I don't know the answer myself, I need to solve it. So first we are saying that list 1 is 1, 2, 3, 4 and 5. So basically list 1 has a nested list, which is again pointing to 1, 2 and 3. Over here I have 4 and 5. Or to write it in a better manner, what I should do is, because it is a list, right? So I'll just clear the screen once. So list 1 is basically, let's take this as a memory block. This is a memory block. So the first index, 0th index, is another list for which 0th index is 1, for which first index is 2, for which second index is 3. Then I have first index, which is nothing but 4, and second index, which is nothing but 5. So now I'm creating a list 2. List 2 is directly pointing to this list, just like list 1. Now I create a list 3, which is a copy of list 2. So copy of list 2 is what? That means list 3 will have like this of a shape, and list 3 will have its own 4, its own 5, its own 4, its own 5, but the 0th index, because it is a soft copy, it will point to this. It will still point to this. And now list 4 is when I will have everything new. 0th index will have again a list 0, 1, 2, which is 1, 2, 3. 1 will be 4, 2 will be 5. Basically these 4 will be same pointed like this than this. Right? Here also it will be pointed to this 4 and this 5. But this list would be again, this all will be entirely separate. That is the key point over here. That is the only key point over here. Now you can solve the question easily. List 1 0.pop minus 2. So we are going to this 0th index, popping the minus 2, which is 2. So 2 is gone. 2 is gone. Then we are saying list 1 is equal to 10. So what we are saying is that list 1, instead of being assigned to here, it will be pointed to 10. So now when you print list 2, you can see list 2 will be 1, 3, then 1 and 2, which is 10 and 5, will be my list 2. Then list 3 will be nothing but 1 and 3 and pointing to 10 and 5. Then list 4 will be pointing to nothing but whatever it was earlier. 1, 2, 3, 4 and 5. And sorry, this will be pointing to 4, right? 4 we took off here. This is still pointing to 4, right? This is not pointing to that. So this will be 4 and this will be 4 and 5. So the correct answer is 1, 3, 10, 5, 1, 3, 10, 5. No, this is wrong. 1, 3, 1, 2, 3. This is wrong. 1, 3, 1, 3, 1, 2, 3. Okay, these two are correct. Out of this, we will have the correct answer as B, because 4 will be in both. So in soft copy, guys, if inside you have another mutable object, those changes will be reflected in the soft copied list. But in deep copy, those changes will not be reflected. Neither of the mutable objects, that is of our list what we are talking about, and neither of the immutable objects. But in soft copy, only the immutable objects changes are not being reflected, but mutable objects changes will be reflected. Okay, so that is the difference between soft copy, or also called as shallow copy, and deep copy. Now moving forward to the 18th question. Which of the following best describes the difference between .iloc and .iat in Pandas? It's a very simple question. Only 30 seconds I will give you for this question. Your time starts now. Very simple question, everyone. Quickly solve it. I'll be sharing these slides here itself. All right, time is up. So what is the answer, everyone? All right, so the answer is that .iloc, we know that can slice internally, right? It can return multiple things. Multiple row and column selection is possible in .iloc. However, in .iat, they both do index based. They both worked on index. Loc worked on name based indexes, name based, and dot at also works on name based, right? But dot iloc and dot iat both work on index, but dot iat will only return one value, a single scalar or one value, and that is why dot iat is faster than dot iloc. Similarly, loc can return multiple slices of rows and columns. Dot at will return only one value or a single scalar, and dot at is faster than dot loc. And the answer is B, that dot iloc allows multiple row column selection using slices and list, whereas dot iat allows faster access to a single scalar value by row and column index. Alright, a very important question, not just for test but for interviews, was what we just solved. So please make a note of it if you were not aware. Now the question number 19th is this question. I'm giving you 60 seconds to solve this question. A pretty simple Python question again. Today actually machine learning I felt was a bit moderate, and I felt statistics, a few questions were moderate. Python, I feel very conceptual questions, but if you know those concepts, these questions were very simple questions. But these concepts are very important concepts. SQL was also good. SQL was also moderate. Especially the coding question was very good. Alright, question number 19. Can you please provide me an answer? I wouldn't even have to solve this. I can easily look at that the loop will run. It will add 4 things, and 4 things are only present in C, and C is the answer. This question is that simple. Alright, time's up. Now I'll be solving this particular question. The answer I feel is C, because there are 4 iterations total. It's the only one that has 4 iterations. But let's understand what if the options were not present, because this question is good. So first, what will happen is we have defined 2 sets, 3, 4 and 1, 2. S3 is a new set that is currently empty. This is S3. Now I is equal to j is equal to 0, but this does not matter, because for I in S1, now what I have started is for I in S1, so I will take first a value of 3, then it will go the control for j in S2, the control will go over here for j in S2, so S2 has a value of 1, so j will be equal to 2, S3 will add 1, so S3 will add 3, 1 to the set. A tuple will be created and will be added. Now what will be happening is I plus equal to 1 will happen, which is I will become now I plus equal to 1, which is I will become 4, and j plus 1 will equal to happen, which will become 2. But as soon as j go over here, whatever value of j is here does not matter. J will take the second value, which is 2. This value does not matter. Let's say if this was j plus equal to 2, this came out to be 3. This does not matter, because the outer control is gone to outer loop control has gone. Basically, the control has gone to the loop for j in S2, not the outer loop, this inner loop for j in S2, and it is saying take the value 2. So now my I is 4, j comes out to be 2, this 2 from here, I is 4, and my set becomes 4, 2. So 4, 2 is being added. Now I plus 1 increases it to 5, and j plus 1 increases it to 2 plus 1, 3. Now this I value does not matter, because this loop first iteration is complete for inner loop. We go to the outer loop, and again we take a fresh value of S1, that is 4. I, that is 4 from S1. So I becomes 4. Then for j in S2, we start the iteration again. Now we will take j in S2, which is 1. So 4, 1 is added. Then I plus 1 happens. So I plus 1 makes it 5. Now I becomes 5. j plus 1 does not matter even if I do, or even if I do, let's say j becomes, let's say, which is nothing but 1 plus 1, 2, does not matter, because this will not matter, as this loop will again take the j from here irrespective of this. So j will become 2 and I from the previous is 5. So 5 by 2 is what will be added, and only correct option I can see is 3 1 4 1 4 2 5 2, which is the option C. All right, option C is the correct option answer. Actually, a very good question when it comes to the iteration, whether you understand what happens to I and j, how do they work with the loops, and if I'm making changes internally in the loop, does that change affect the control of my loop? If I'm directly picking up from an object like a list or a set, it does not, right? All right, so now moving on to the last question, which I will be giving to all of you as a homework that you need to solve on your own, and we'll be solving in the next class, is this particular question. 1 second. So we can see C is the correct answer. So question number 20 is what you need to solve. You can have a look at it. And I will be sending this to the chat. All right, so this is the last question, guys. You all can practice. If you're preparing for data science role, you would need to do the lead code. Right, that's it, guys, from my end. If you have any questions, feel free to ask. Otherwise, I will be signing off. Please don't forget to like and hit that button, whatever that is called, subscribe one, right? If you enjoyed it, so that it helps our team stay motivated, keep driving all these sessions forward. There's a little lag in the stream, so you get the link earlier, and in there you get it late. That's why. Okay. I see no more questions. Thank you so much, and have a good day ahead. We'll see you tomorrow with some interview prep. Let your friends know. Let your other folks know, right? And help them as well. Thanks, everyone. Have a good day ahead.